Welcome everyone. I am Betsy Stratton. I'm a project manager at the National Renewable Energy Lab, or NREL, as you'll likely hear a lot about during this session. Might as well familiarize yourselves with that acronym then and now. I'm here today to welcome you all to the Marine Energy Career Panel, which specifically is going to be featuring professionals from 3 of our U.S. Department of Energy national labs. Now, before we kind of dive into the good stuff, I just wanted to give a brief overview of our national lab system. So again, the U.S. Department of Energy established 17 national labs to tackle some of the country's largest priorities and scientific challenges related to energy, climate, the environment, et cetera. Each lab has kind of a unique capability or unique set of or areas of expertise. But with the overall common goal to strengthen the US's global leadership in science and innovation. And some of the ways that the labs are doing this collectively, but in their own kind of right and ways, driving new energy technologies, advancing scientific discovery through research with the goal to protect national security and train our next generation of energy workers. And so today, like I said, there's 17. We're going to be featuring or representing 3 of our 17 national laboratories, including National Renewable Energy Lab, or NREL, the Pacific Northwest National Laboratory, or PNNL, and Sandia National Laboratories. Yeah. So yeah, I'm not going to get into too much detail there, since we're going to be hearing from some of the folks from these labs in just a moment. So I want to get into the good stuff and not delay too much. But before doing so, we just wanted to provide a little bit of information at about each of these national labs. Specifically, and starting with NREL, located in Golden, Colorado. There's also a campus location outside of Boulder, Colorado. It's the primary national laboratory for renewable energy and energy efficiency research and development, with a focus to some degree, or a portion of the focus being in marine energy and hydropower systems. And then we are also going to hear from folks at PNNL, which is home to 6,000 researchers and support staff with the main campus in Richland, Washington. And then there are additional offices in Sequim, Seattle, and Portland. The Sequim campus hosts a marine energy laboratory featuring bench-to-bay operations for testing at various scales and a significant focus on marine energy. And the 2 main projects at PNNL that will be hopefully covered pretty heavily today are on environmental effects of marine energy, which include the OES Environmental and Triton projects. And then our 3rd lab that we're going to be hearing from today is the Sandia National Laboratories, which employs about 15,000, mainly located in the Albuquerque, New Mexico area. It provides expertise in engineering, security, and renewable energy innovation. In marine energy specifically, Sandia leads efforts in device design, testing, and modeling, particularly through its Wave Energy Converter Simulator, or WECSIM, which again is another acronym to familiarize yourselves with, and research on materials controls and performance optimization for wave and tidal systems. So with that, I will hand it over so we can do some panel introductions.
Perfect. Thanks, Betsy. Yeah, so today, as you hopefully know, we are doing a marine energy career panel. So today we've selected several panelists to show kind of a broad range of different careers within the marine energy field at the national labs with a breadth of backgrounds. So we're going to start by each panelist will introduce themselves with 1 slide. Then we'll go through some prepared questions for the panelists related to career paths and development and skills and such like that. And then we'll move to some Q&A discussion. So feel free to put your questions for the panelists in the Q&A box. I believe you can find it by looking at the bottom of your Zoom screen or on the More dot. So feel free to put questions there, and I'll hand it over to our first panelist now.
Thanks. Hi there, my name is Emma Cotter. I'm an ocean engineer at PNNL. And before joining PNNL, I completed my PhD in mechanical engineering at the University of Washington. So while I was at the University of Washington, my PhD research focused on the development of an integrated instrumentation system for environmental monitoring at marine renewable energy sites. That's that big blue sensor package that you can see in the middle of the slide. After my PhD, I traveled across the country for a postdoc at Woods Hole Oceanographic Institution. There, I worked with a different ocean instrumentation system that was designed to study the deep ocean, but also an integrated package with a lot of different acoustics and cameras and other sensors. So you can see that instrumentation system to the top left, just above the other one. After that, I ended up coming back to the marine renewable energy space at PNNL in 2021, and I've been working here ever since. At PNNL, most of my research focuses on developing new tools for environmental monitoring at marine energy sites, including as a part of the Triton project that was mentioned a couple slides ago. And I've also just applying the tools that we already have to conduct that monitoring. One of my favorite projects that I've worked on at PNNL was conducting passive acoustic monitoring around a riverine turbine in Igiugig, Alaska last year. You can see a photo in the middle there of me at the river at the site. Outside of work, I like doing pretty much anything that gets me outside. Lately, that's meant a lot of riding bicycles and climbing, but I'm generally happiest when I'm outside. Thanks.
Good afternoon, everyone. My name is Courtney. I have been at NREL since 2024 as a full-time employee. Prior to that, I was an intern in the Marine Energy Group. I completed my undergrad at the University of Maryland, Baltimore County, UMBC, Go Retrievers, in mechanical engineering. And I then went to grad school at Carnegie Mellon and got my master's in engineering and public policy. Now I kind of am a retired engineer. I don't do much technical work anymore. A lot of my work focuses on policy, especially surrounding commercialization, as well as community engagement work and resources for communities who are interested in marine energy. I also do some economic analyses of energy solutions. Yeah, so the pictures, uh, some of them are kind of related to the things that got me interested in this space in the first place, like our infrastructure challenges as a nation. A lot of my master's degree was focused on doing cost and benefit analysis and how that can be used for technologies, and just the intersection of people and systems and energy. So outside of work, I like to travel and I like to be outside, though I don't think as much as Emma does. And I like to bake and go to museums. And if you go to that very top, the top corner, that's not my face, that is the Starship Discovery, which is here or near me in Chantilly, Virginia. And yeah.
Hey everyone, my name's Rashid Arbali Zamora. I am from Sandia National Labs. I've been at Sandia since 2019. I have a bachelor's degree in electrical engineering from University of Puerto Rico, a master's also in electrical engineering from the same university. At that point, I was mostly focusing on satellites and power electronics. Applications for in the aerospace realm. 2019, I graduated with a PhD also in electrical engineering, also from University of Puerto Rico, and it was mostly focused on grid integration. At Sandia, the work that I do is looking at controls for microgrids and other power systems that include distribution and transmission. The work that I specifically do at Sandia that aligns with marine energy is more looking at power electronics, the inverter, power converters, anything required to interconnect those systems to the electric grid and what controls and functionality can be enabled in those power electronic elements to not just provide power, regulate power, but also provide additional grid services as they align to grid codes and standards. In addition to working at Sandia, I'm also an adjunct professor at University of Puerto Rico. In my spare time, I like to be out, I volunteer, and I like to cook. Maybe a little bit too much, but I will pass it on to the next panelist.
Thanks. Hi, everyone. My name is Haley Farr. I'm an environmental scientist at PNNL. I've been here for about 6.5 years, and before that, I studied biology and ecology at Cal Poly SLO. That school, their motto is learn by doing, so they really encourage undergrads to get involved in research. And I actually started in algae and biofuel and quickly transitioned to what I thought was a lot cooler, which is offshore wind, and looking at the environmental effects of floating offshore wind, and particularly in deep waters like we have here off the West Coast. After graduating, I volunteered at conferences to sort of network and meet people, and eventually ended up at PNNL as a post-bachelor's RA or research associate. And I've been here again 6.5 years since in our coastal sciences division. I primarily research offshore wind energy and marine energy's environmental effects, kind of looking at wave, tidal, and ocean thermal energy. And then in addition to a lot of the environmental effects work with OES Environmental, which I know was mentioned, I do a lot of the data sharing and development work for a lot of the online resources that the labs support. So all 3 of the labs represented here today support the portal and repository for information on marine renewable energy, or PRIMER. And one of those knowledge hubs I support primarily is TETHIS, which focuses on environmental effects. So I do a lot of the outreach and engagement for those websites. And I just highlight the TETHIS Blast and the PRIMER Blast newsletters as 2 resources that I support and that I would really recommend all the attendees go and subscribe for, just to kind of stay up to date with the industry. And then I think there's a theme with a lot of us outside of work liking to get into nature. I'm based in San Diego, so I like to get down to the beach and go surfing and climbing as much as possible. And that last photo on the right is me climbing near a wind farm out here in San Diego. So glad to be here today. Thanks.
Hi, everyone. I'm Bree Friedman. I'm a researcher at NREL. I started as a mechanical engineer, studying at Virginia Tech, did both my bachelor's and my master's there. During my master's, I was mostly focused on drone work, helping start a drone academy in Malawi, Africa, and doing some research on flood modeling. During my bachelor's, I also was a SULI at NREL, doing actually solar work. You'll hear more about the SULI program later. It's a great opportunity. And I did a bunch of undergraduate research at Virginia Tech, which led me to my master's, and then that drone work led me to being a postmaster's researcher at PNNL, where I was doing some work there for 2 years, kind of transitioned into marine energy while I was working there. And then I left PNNL and joined NREL in 2023 as a researcher on the water power technology validation team. At NREL, I'm working on different wave energy converters to be deployed, and then I also help industry test their devices. That bottom middle photo is our large amplitude motion platform, so it tests wave energy converters out of water, and so I help industry test their equipment on our tool. So yep, mostly focused on designing, building, and deploying wave energy converters, testing on our large amplitude motion platform, and then also I do some technical support for prizes that grow the marine energy community and build our industry. And in my free time, to continue the theme, I like to be outdoors, do a lot of climbing and hiking, and I'm based in Boulder, Colorado.
Great. Thank you, everyone, for introducing yourselves. At this point, we're going to kick it off with some of our prepared questions for the panelists. So feel free to jump in and respond in whatever order you feel is most helpful. Our first question today is, how did you initially get involved with your subject matter? And what would you suggest someone to do to get involved if they are interested? And kind of a part two on this question, really packing it all in, is did you have an aha moment and what was it?
I'm happy to go first so no one steals my answer. Um, I got into marine energy. Obviously, I learned about floating offshore wind first, but there's a lot of similarities in the technology. So I actually started reading a lot of the work that came out of PNNL and OES Environmental as an undergraduate, learning about floating wind and kind of just getting my feet wet in marine energy. Actually started it was an argumentative writing class, and I just thought looking at the wave energy community and the surfing community and potential conflict there would be an interesting subject. And from there was encouraged to get involved in undergrad research and start working on a paper and going to conferences. So I really credit that to a lot of the professors I was working with at Cal Poly. But in terms of actually getting in more into the industry, I volunteered at conferences and tried to meet with as many people as I could. I tried to do informational interviews where you kind of learn about different career paths, and similar to this, just hear about different strategies and options for careers in marine energy. I eventually attended the Ocean Renewable Energy Conference, OREC, in Portland every year. It's a great conference. I love the organizers of that poet, and was able to meet with a lot of the staff members at PNNL, and actually some of the other labs as well, and just get sort of ingrained in some of the projects there. So I definitely credit, unfortunately, networking to helping with getting involved in the industry. But fortunately, everyone is extremely kind and extremely welcoming, and it's still relatively small community. So there's a lot of opportunity to kind of get plugged in and connected to something you're interested in. I'll let someone else speak now.
I think for me, with a background in mechanical engineering, just like acknowledging that mechanical engineering is really broad. And, you know, I went from drone work to marine energy work, and it doesn't necessarily sound like there's a lot of overlap there, but there is a lot of overlap there. And I think being open to pivoting to what you want to pivot to, and I guess based off of what Haley said, like making those connections. I joined PNNL to do some work that was more related to drone work, and then had some coworkers who were doing marine work that I was interested in, and was able to talk with them and see if they had more work that I could help with, to kind of pivot more into marine energy, knowing that I was interested in marine energy work.
I'll chime in. When I was in grad school, I didn't really know what I wanted to do. I was a little bit lost. I hadn't started that soul searching part of what do I want to do with what do I want to do after graduate school. But in 2017, Hurricane Maria had hit Puerto Rico, and there was a massive power outage, and I did a lot of volunteering, helping with community members, just distribute food, and just seeing that, I guess, motivated me to get into a space where I could help communities have their own energy independence. So Sandia, in a little, sorry, a little bit after that, Sandia had traveled to University of Puerto Rico to do recruiting, and I talked to a manager that gave a presentation, and he was interested in me going to Sandia as a summer intern. And the more I learned and the more work that I saw that the national labs were doing, the more interested I was. And ever since, I've been working in this space of just how to make the grid better.
I can jump in. I also, I think, sort of stumbled across the space that I'm working in. When I was applying to grad school, I knew that I wanted to do research that was related to energy and the environment, but didn't really have super clear idea of what I wanted that to look like. I sort of realized as I was talking to professors at different schools, actually a lot of the things that really piqued my interest were related to sensing. And so I ended up taking on this project related to underwater sensing for marine energy. not really knowing what marine energy was before I started talking about it. But it was a great decision that really shaped my career.
Great. All right, I'll move to our next question, which is, what does your job look like day to day? And provide some behind the scenes details if you can.
I can start. So I actually work remotely and have for the last 2 years or so. So most of my days are at a computer working from home. I spend a lot of time on calls, collaborating with folks who either also work remotely or at the lab. And I also end up traveling quite a bit, whether that's to conferences or to the lab at PNNL's SQUIM campus, or to other sites for field work, like I mentioned in my introduction. So I think my days, most of them are, working from home, but I do end up traveling and having a lot of sort of different experiences that way.
I also work at a computer quite a bit, working on planning projects, planning deployments, designing test setups, designing systems, data analysis, but then I also get into the lab quite a bit. So running our larger equipment, troubleshooting, a lot of banging my head against the wall to try to solve problems, and then building and working with technicians to build our test equipment. Yeah.
I also work from home. I'm sorry. I spend with the policy work, I spend a lot of time reading, honestly. So a lot of that is journal articles and, previous NREL and other lab publications about relevant topics. I do get the opportunity to do outreach to potential research leads, which is really cool. So like a couple weeks ago, I got to talk to somebody from the Washington Department of Ecology and like conduct an interview that was, really helpful to some of our research outcomes. But yeah, it's a lot of sitting and then standing up and stretching and figuring out where you can go read your next article that will be comfortable.
I can
Yeah,
go next.
oh, go ahead.
Oh, no, after you.
I was just going to echo everyone else. I think working remotely, you are stuck to your computer quite a bit, but I've definitely tried to work in dog walks throughout the day or walking meetings when they're feasible, to try and break it up a bit. Traveling for conferences is definitely the highlight, and putting on workshops. I've gone to do a couple like interview related projects where you sit down and speak with people about their experience and expertise, and that's always really rewarding. A lot of what I work on is very similar: reading, writing, and kind of curating a lot of the online resources we support in the websites. So searching the internet for small details, and finding information that way. Yeah. Rashid, go ahead.
So I am located in Albuquerque, actually, but I'm a little bit hybrid. Sometimes I work from home, sometimes I go into the lab. I wear a few hats, so program manager, project manager, and just the standard researcher. There is a combination of meetings, supporting projects, supporting programs, networking with customers, meeting with stakeholders, ensuring that each project is aligned with the stakeholders' expectations, while at the same time meeting your customers' deliverables and milestones. In the researcher side, there's a lot of simulation modeling, validation, experimental testing. There's some field deployment also. There's a lot of writing and reporting.
Great. everyone. I'll do one more prepared question, and then we've got some great questions coming into the Q&A box. So a reminder to put your questions in there, and we'll get to them if we can. So this question is, what has surprised you most about your career in science or in marine energy? And what would you have liked to know as an undergraduate or graduate student?
Yeah, I want to take this one. So, Bree kind of touched on this earlier, which was I think you have to be very comfortable pivoting to your area of interest. I definitely have had experiences where people will ask me what I do, knowing that I went to school for mechanical engineering, and when I say, "Oh, I do marine energy policy," they go, "What are you talking about?" And I think that's about like figuring out where you can kind of carve out a niche for yourself and where your research and skills will be most valuable, and also where your passion lies. Like in my mechanical engineering degree, I knew that's not something that I wanted to continue doing forever. I liked engineering fine, but it wasn't like what drove me, and I was very scared, I think, to like make the turn because I didn't know how to connect, my engineering interests with my policy interests. Um, and so putting myself in different spaces, like I was a gym fellow and I just applied to a bunch, whoever would take me. And that's how I ended up at NREL. I think that was like a really big part of my journey. I also wanted to say, like, in terms of things that are surprising about a career in science, I think coming from an engineering background, one thing I think it's really important to know social sciences very well and like to spend time in social science. I think a lot of that's not always emphasized in an engineering education. But being able to write well, being able to communicate clearly and effectively, and keeping a mind toward larger social issues, like looking at the role that community engagement plays in the marine energy space, and also how tribes and other groups are affected by certain outcomes in energy. So I'll stop there.
I
Oh,
think, oh, go for it.
all right.
I think one thing that surprised me was, I guess I don't know, when I was in undergrad, I kind of expected to dive into one of my subjects, like dive into heat transfer, and that was my career. However, I was applying it. And I'm sure some people have that experience, but for me, my work has been really, really broad. From one day I'm designing structures that can carry a heavy load, another day I'm doing data analysis, another day I'm working on controls. And so I think looking back, school was really, or undergrad specifically, was really more just giving me a toolbox of like knowing where to go and where to look to solve problems. Not necessarily memorizing everything I learned in school and knowing how to solve them right off the bat, but giving me a toolbox to like look into. And I think having that perspective during undergrad and during grad school would have been really helpful for my career.
I'll chime in real quick. What surprised me the most is how sometimes little actions can have really big impacts in different ways. When I started, I wanted to change the world because everyone wants to change the world. But you can do that in different ways. I brought in a lot of members of staff to work under some of these projects, and it helps build their career. And we brought in interns from different universities, especially my university. And sometimes being involved in those projects can define their career, it can create opportunities. Sometimes it pays for their graduate school studies. In the long run, I think that those changes are also important. It's taught me to look at the world a little bit different. So the change doesn't have to be just technical. You can also make changes in people's life that define their career, the education.
Right, great. We'll jump to a couple questions from the Q&A box. And if any of the other panelists see any of those questions and you feel like it's a quick one to type an answer in, feel free to do that so we can spend most time discussing questions that are as broad and relevant to others as possible. I see Courtney starting to answer one maybe, but the question I'm going to ask to y'all is, what are the pros and cons of doing a postdoc, or I think I heard other folks say postmasters, postbachelors? Is it necessary to get certain positions, or what was your experience there?
I can jump in on that one as someone who did a postdoc. I think, well, I guess sort of two perspectives on this. One, at least at PNNL, my perception has been that many people who join the lab with PhDs either join the lab as a postdoc first, or have done a postdoc or worked somewhere else first. That's not a hard rule, but I think that's at least a trend that I've observed. In terms of, I think, the advantages or disadvantages, obviously it's more time in your life. It's potentially moving across the country again, which can be challenging, and the uncertainty is really difficult to deal with, the sort of short-term positions. But I personally found doing a postdoc for me was really beneficial because I took it as an opportunity to really stretch my skills and learn new technical skills. So I had worked a lot more sort of on the data science side, working with data during my PhD. And during my postdoc, I was able to dive a lot more into the underlying physics of how those sensors worked. And so I found that gave me a really nice complementary skill set that I use in my job every day. I think there are a lot of different ways that people sort of use postdocs. But for me, I think it was a really good step for my career.
I mean, I can just speak really quickly to the post-bachelor positions that the labs offer. I think they're a great opportunity, especially coming out of an undergraduate. There are very limited options to get you really interdisciplinary experience in kind of a lab setting that has a lot of the academia feel and the private industry going after funding opportunities as well. I think there are 2-year positions for postbaccs and postmasters and 3 years for postdocs. So there's definitely it's short term, but enough opportunity to kind of get ingrained in the community and network within the lab. It's not a guarantee, but there is opportunity to then stay on the lab, which is obviously what I did. But it's also a great experience to put on your resume to then go on to other government related or industry consultancy jobs within marine energy or other industries. So I definitely recommend them. Most people I've spoken to would also recommend them and have transitioned either into the labs or into another field where they really valued their experience.
I think it's also worth saying it's not like many people join the lab in postgraduate positions, but it's also an opportunity for you to sort of try it on and see if the lab is somewhere you want to stay. And it doesn't, on your resume, you aren't immediately leaving a job if it's not a good fit. There's sort of a natural exit point if it's not a good fit. So it's a good opportunity to see if it's what you want, and potentially open up other opportunities as well.
All right, the next question from the crowd is, how do you collaborate with industry? And anything you would recommend for folks just starting the career if they wanted to join a marine energy technology developer or work with a developer?
So I can answer at least the first part of that, of collaborating with industry. So I do testing at NREL. We have a lot of test equipment. So we'll have industry come in and use our test equipment to test their device. So that's kind of how we collaborate with industry. They get funding from the Department of Energy that then funds their testing at our campus.
For the work that I do, I attend a lot of industry-led conferences, and usually through those conferences, we build a relationship. Either we submit joint proposals that focus around some of the challenges that industry could be facing. It could be manufacturers of power converters, it could be utilities. Usually, I, at least in my work, take that approach. So identifying stakeholders in the relevant space that I am working on, and then trying to solve some of their issues. Sometimes last week we had a distributed wind power converter manufacturer come in, and we were testing one of his power converters, and they're having issues and some challenges with certification. So we partner and we work together. We use our advanced facilities and we try and identify a path forward for their power converter to be standard compliant and for it to be something that is beneficial for the grid.
I'll also say that a lot of my interactions with industry are through testing. I think Bree mentioned the Department of Energy funds testing. A lot of that's through the Teamer program, which there are many different institutions listed as facilities that have either something like a wave tank, or they have a capability like the ability to model a turbine. And then companies or researchers can apply for support through that program. And so that's been a really great opportunity to work on some different interesting things and interact with industry.
The next question is, what kind of experiences or keywords would you be looking for on a resume submitted to be one of your coworkers or someone working at the labs?
I could take a stab at that. I, I don't I don't think that there is one like specific profile that I think one of the things that makes the labs a really special place is that you have people from a lot of different backgrounds, um, who all kind of are coming at this marine energy problem from different perspectives. And I think the the combination of those different perspectives is part of what makes a lot of our teams so successful. I think the most important thing is that you want to be where you are, and like you have an interest and you have a passion and you're open to learning, because like there's just always so much to learn. Every single day is like a new learning experience. Um, I think it's helpful to have research experience because research is its own whole process. But yeah, I don't think that I don't know if there's a one size, like one thing that I want to see.
I think speaking to what Courtney said a little bit earlier as well, as just interdisciplinary experience and kind of having experience with communication and technical work, just becoming a full rounded person. I think that really shows during interviews as well, not just on paper, but showing that you're passionate about the work and may not have, I mean, marine energy is a very small space, so you may not have experience with that specifically, but if you can apply your skills and show that they will transfer, that's always great. There's also a lot of opportunities through like the Marine Energy Collegiate Competition and internships that when we see you're trying to get involved in the space, that is definitely a plus up in terms of looking at resumes.
I'll also say, at least in my opinion, when I've been looking at these things, I think that cover letters matter a lot too. particularly if you don't have direct related experience, but it's something you're really interested in and you think your skills would apply, that's a great place to lay that out, how you would apply those skills. And so I think sometimes you see a resume that doesn't have the experience that checks the boxes you were looking for, but maybe a person really communicates their enthusiasm about it and how they're, ready to apply the skills that they have to the new topic.
Right. The next question I'm going to ask came in through the Zoom registration box. So this question is, did you have any mentors who supported your career path, and how has this helped you? And how might you go about connecting to a mentor?
I'll jump in and answer this one. When I started as a graduate student, as an intern, I had a mentor that supported just helping me be familiarized with the research facilities, with the softwares and tools that we use. And I would say that that was critical. I think that over the years, I've had different mentors that help in different spaces. I encourage everyone that is interested in doing research, whether it be marine energy or any other field, to have a mentor and to be a mentor to new staff. I think that is also important because no one is taught how to be a mentor. You just try and you just try to do your best. But I think that you will benefit a lot from being a mentor, and you should give that. You should give back and also be a mentor to students, either graduate or undergraduate, and to other new early career staff members.
Yeah, I would definitely echo that. I've had a lot of mentors to get to where I am. I think so. If I start in undergrad, I had a mentor who was just a professor, not in my field, but like helped me figure out what I wanted to do. And I think it is helpful to have a mentor who's in your field and mentors who are outside of your field, to kind of get a wider range of perspective. And sometimes I think, like, if I had had just a mechanical engineering mentor, I think I would have been pushed more toward mechanical engineering, and having that diversity allowed me to like be flexible. I've also had mentors here at the lab. I part of how I got those mentors was my fellowship program. So I was a GEM fellow. The GEM fellowship GEM does not stand for anything coherent, but it's what it essentially is it helps students who are minorities are interested in a graduate education. So I was a GEM fellow, and through that, that's actually how I was connected with NREL. And one of the people who I was connected with, she was majorly instrumental in helping me learn more about the marine energy industry, but also helping me get this job. Um, I will also say once I got to NREL, I was able to join employee resource groups. Um, and that connected me with another mentor. I'm a Black woman, so I was part of the Black employee resource group, and that's how I connected with another one of my mentors. So I think it's about putting yourself in just as many spaces as you can and being like, please teach me things. So yeah.
I also want to acknowledge that like I feel like I have a lot of, unsaid mentors of just like people I've looked up to or looked at their career path, that probably aren't like official mentors, but just like I think it's important to have people who are like supporting you in your career and who you can ask questions to. But it's also important to just like, I guess this goes more to networking of just like understand what different people are working on and what interests you. Um, yeah.
Great. All right, the next question is kind of a mashup of a couple different ones. So the question is, what are some certifications or classes or other kind of professional education, continuing education that you found helpful in either getting started in your career, like a class you took in undergrad, or an ongoing education effort that you've taken now that's been helpful in your career?
This isn't quite a class, but for me, it was definitely undergraduate research while in undergrad, and also doing a SULI, which is a undergraduate internship that I did at NREL. And those just got me more into the research space, which was critical in like going to grad school and ending up working at a lab.
I'm gonna echo that. I don't know. Well, working, so because I do policy work, my graduate education was largely focused on taking policy analysis style courses. And I think that gave me a lot of experience on the economics of like solving problems and how things happen from not the engineering side, but from the legislative side. So I think that that's important. But I also want to echo that part about doing undergrad research. So when I did an REU, which is a research experience for undergrads at the University of Pennsylvania, at the Laboratory for Research on the Structure of Matter, which is a material science lab, and I ended up on a soft matter physics project, and I hated the whole thing. And I think it's important. That was a really important experience for me because I learned that I did not like doing that type of work. And I thought it meant that I didn't like doing research, but then I've also conducted research in like the pedagogy of the College of Engineering and Information Technology at my undergrad university. So I think having enough experiences to know what you like is huge.
I'll mention something. Last year I did something called Energy I-Core, which is an entrepreneurship course funded out of the Department of Energy, where you look at commercialization and opportunities in the who could buy your product space. I think I think that helped me a lot, especially when I submit a proposal nowadays, because it gives me an idea of I'm proposing this project. Is there a market for it? Is it important? Is there a need? So that really did give me a little bit of a lens. So I appreciate that I was able to take that. For those that are not in the national labs, when I was in graduate school, I took NSF I-Core, which is more focused at university students. And it was a similar course. It was more of a crash course, and the DOE Energy I-Core is a little bit more focused on a specific energy related technology. So I would encourage anyone to look into those opportunities. There are opportunities inside labs. There are programs inside universities that are looking at entrepreneurship. I think it's important because you want to develop a technology that can be commercialized or that it's going to have a real world application. You don't want to develop something that's going to generate a patent that's going to be shelved in some drawer or put in a drawer. So that really did open up my eyes in terms of the research that I wanted to do.
I would definitely echo the undergrad research and internship experiences. If you can, over the summer, do paid internship, definitely better than unpaid, but there are a lot of unpaid internship opportunities out there. I would also add just some like, they're not soft skills, but classes in areas that you're not required to take with your coursework. So I was taking a lot of lab work and science classes, so I tried to kind of balance that with some communication classes and a lot of philosophy classes, which at the time felt very random, but I got to take a lot of cool philosophy of technology and philosophy of warfare and classes that kind of make you think and argue and learn how to collaborate with other people. which are definitely big skills in the workplace, no matter where you end up. So I would just take the opportunity while you're in school right now, hopefully, to take as many cool classes and random topics as you can.
Right. The next question I'll ask is kind of building on what Haley was talking about there. What are some other important skills needed to work in this area, whether that's in your specific role, soft skills, hard skills? What are kind of the top things for you?
I feel like across, like we have panelists from a lot of disciplines that work on marine energy. But one thing that I think spans a lot of disciplines is data analysis skills, and the ability to analyze data and clearly communicate the results, I think is something that probably comes up for all of us, and is a really useful skill to have.
I would also add problem solving. I think that's probably across the board of just you're given a problem, how are you going to troubleshoot that problem or kind of chip away at it to make it a smaller problem or an easier to solve problem or something that can be distributed between people. And I guess that also leads to communication, like how can you communicate effectively of your findings to the public, but also how can you communicate effectively within your team?
Right. The next question is, what is the current marine energy industry outlook? Kind of what do you think this industry will look like in 5 years or 20 years? And on that note of skills, what skills do you think the future workforce will need to be successful if things are going to be different?
That's a very difficult question, I think. I think that depends on a lot of things that we do not know. So I'm going to talk about it from a policy side. I think that obviously the foundational R&D and technological development is, critical to any projects. But I think one of the things that we don't always focus on in the marine energy space is the need for enabling policy mechanisms to allow those devices to be in the water and to be used by people, right? And there is a lot of really cool and interesting work that I'm seeing that I'm involved in right now that is looking to enable those pathways to um, eventually, you know, hit some critical mass so that this industry, is really lifting off the ground. Things are different in the US than they are internationally for marine energy, for sure. Um, so, it depends. It could go a lot of different ways. But I still think regardless that it's really important and really fascinating. So.
I think that important aspect that's going to come up is grid codes and standards. A lot of interconnection standards for different generation technologies, solar, wind. They require grid codes, and utilities abide by those grid codes. And you could have the best wave energy converter in the world, and if you have a power converter that conditions that power for the grid and the utility, and it's not certified by UL, the utility requires that it be certified by UL, you can't connect it, so it creates a bottleneck. I saw it. I've seen it in solar. I've seen it in wind. It will happen for wave energy conversion, but there has to be work in all the spaces. Once some of these wave energy converters are widely adopted to be interconnected with the grid, if the converters aren't certified, I do not envision that there will be a large industry for building some of these converters. So they will not have the capital to support constant interconnect. And some of the standards require a lot of tests. Yeah, I do not envision that they will be prepared to be developing an inverter that is able to handle the oscillations that come from wave energy conversions, while at the same time providing all the requirements. So getting familiarized with existing standards, what are the challenges that other industries have faced or are currently facing, is a good way to prepare the wave energy converter industry. I think there's an opportunity there because I envision that it will push deployment of some of these technologies years, even if the converter is at a mature deployment stage.
Just to add from a more environmental effects perspective, I do think that a lot is being done internationally, and there are a lot of opportunities to learn from that. But we definitely need to see more development in devices in the water, steel in the water. It's a common phrase we hear at conferences, but just getting more monitoring and understanding of what the impacts are. I think generally we can deploy these devices in a sustainable manner. We just need to have those kind of success stories to show the future and the potential for it, whether that's on sort of smaller scale applications and powering the blue sea kind of applications and unique novel applications of these technologies, or eventually getting some kind of grid scale powered projects out there. I think there's definitely opportunities, but it's just bringing that funding in and continuing to do the research and deployments and improving the technology.
Great. All right. I have one last question to pose to the panel, but I want folks to make sure to stick around. We're going to go through a lot of the internship opportunities. I saw lots of questions about that. We're going to present a few more slides on internships and some other programs. They are geared more towards U.S. citizens. So I saw a question about international resources. So we'll think about that a little bit more and see if we can dig anything up to send out to you all. But the last question I have for the panelists today, and I'd love to hear just a quick bit from everyone, is what makes you curious day to day in the marine energy field?
I think a big thing for me is just how much we don't know. Marine energy is a small industry, and it's, newer than some of the other renewable energies in terms of researching it. And so I think I just get so curious about how many questions have yet to be answered and how many things we have yet to learn.
From the environmental monitoring perspective, one thing that makes the job really challenging but also really interesting is that the areas where we want to deploy marine energy are the most energetic parts of the ocean, which means they're the hardest parts to do science in. And so there frequently aren't existing methods to collect the kind of data that we need, or the sensors that would be used in another environment don't work as well. So it creates a really interesting challenge to figure out how to work in this environment.
Yeah, I have sort of two answers. One is I think looking at how do we make this happen? Like we have all of these great devices, like how do we get it out there and navigate the regulatory timelines, which are intense for marine energy. And it's also kind of this sense of wonder of the like engineers and what they're able to do. Like I found out a couple months ago that there's actually a wave energy project maybe under development in the Great Lakes, which does not have super strong waves. And I was just like, wow, we can do anything. So that's kind of inspiring.
Yeah, I'll just echo what Courtney said. I think there's a lot of really cool opportunity with this crazy technology not a lot of people know about. What's keeping me interested right now is ocean thermal energy conversion, OTEC, and just kind of the wide scale opportunity there if we can get the funding and advance the technology. So I think it's just like how big can this go and how much can we cover with marine energy and how can we do it as sustainably as possible at the same time, keeping in communities and everyone involved and engaged and trying to be like a model for a good energy community dynamic.
All right. Well, with that, I'm going to turn it back over to Betsy to walk us through some of our last opportunities. We are going to send out a follow-up email to everyone who registered for this with the recording, so you can dive into those answers a little more deeply, as well as see if we can follow up with some additional links to resources. So over to you, Betsy.
Thank you so much. And thank you again to all of our panelists for participating and for everyone for giving such great questions in the chat. Before we finish up, we just wanted to share some of the exciting opportunities that we have for students and recent graduates. And I think we even have an opportunity for some faculty in case there's anyone on that call on this call today. So yeah, one of the opportunities is the Marine Energy Fellowship Program. And I think we had a question in the chat about PhD opportunities. So current graduate students, both in masters and PhDs, as well as recent graduates, are eligible to apply for this fellowship. It's encouraged and open to both STEM and non-STEM disciplines. And it's just really a great opportunity for hands-on experience with field research and testing, which is a skills and an experience gap that's been identified by employers in some of our assessment work. So it's a really great opportunity to gain some of that skill sets. And then most importantly, I just wanted to flag the important dates that are coming up because we are currently in the application window period for summer 2026 term. And so you have between, well, now up until December 2025 to apply. So keep that deadline in mind.
Betsy, just a quick clarification. Applications have not opened yet. This is just speculation.
Okay.
Sorry. But
No, thank you.
hopefully to watch her and
Everything's pushed back a little bit
Yeah.
these days. So yeah, thank you for that. So hopefully we'll have some more information. We actually have a few kind of newsletters and things like that at the end of this that you can sign up for, where I'm sure like Ariel, thank you Ariel for pointing that out, that we'll maybe provide that update when those are open. So I'll get to that in just a moment. So yeah, good. Go to the next slide. Thank you. So yes, Suli, I think this was mentioned several times by the panelists today. So evidently it's a really great program. It's the Science Undergraduate Laboratory Internships Program. So that's both for undergraduates and recent grads. And it's a internship at one of the 17 national laboratories where you'll be paired up with a lab mentor and work on a specific project related to DOE's overall mission. So you'll be able to leave a really big impact and gain some great experience. And then the one faculty advisor or faculty, excuse me, opportunity is for visiting faculty programs where over the summer, faculty will be able to collaborate with DOE researchers as well. So both of these are really great entry points for building connections and gaining lab experience. And again, Ariel, jump in if these dates are maybe wrong, but we don't
these
have
are just the general yearly timeframe. So these
we
ones
don't
are
have
okay.
exact. Yeah, we don't have exact. This is the general kind of approximate start date, but I believe the next deadline for the spring 2026 term is October 1st, according to the website online. So I think that one we can rely on. So thanks for that. And then next, we have a few postdoctoral fellowships. NREL, PNNL, and Sandia all offer different programs along those lines, as well as other national labs. So there's kind of a broad pool that you can look to. And then there are also programs like the Graduate Student Research Program through the Office of Science that create pathways and support and provide support for someone to advance their PhD thesis research while at one of the DOE national labs. So another good PhD supported resource. And now this one I'm particularly excited about, but that's because I'm biased and co-lead this program with REL. But this is the Marine Energy Collegiate Competition. It's an annual student-led competition managed by NREL through funding by the U.S. Department of Energy's Water Power Technologies Office. It's engaged hundreds of undergraduate and graduate students each year from academic institutions across the country, and we've had some international participation as well. And it's funny, I was actually looking at the attendee list, and it appears we have some MEC alumni on this call, which is always really great to see. So if you know, you know, and it's nice to see you guys. And then just providing a little bit of information on this year's competition, which is right around the corner. Applications are actually closing this week, so I'll get to that in a moment. But this year we are introducing 2 leagues rather than just sticking to one. And so to provide some kind of flexible participation for new schools and those just interested in getting their feet wet. And so there's a kilowatt challenge and a megawatt challenge. The core challenges are pretty much the same from over the years. Opportunity to develop a business plan, technical design, do a build and test for your prototype, and a community connections challenge. And it's pretty great. I mean, you get a lot of hands-on experience. Now you get a lot of network opportunities and access to industry contacts that we have made over the years. It's really great for skill building and opportunities to boost your resume. I think there was a question about, what are we looking for? What are current employers looking for as far as skills that they can list, and these types of things, these hands-on experiences, testing prototypes in wave tanks, things of that nature are really desirable. And then potential cash prizes, which who doesn't like? But yeah, so applications are closed in 2 days. September 19th. We close them at 11:59 p.m. Mountain Time. Strongly encourage those who are interested in building a team at their school to do so. And the application is relatively simple, so don't be deterred by the 2-day deadline. Okay, yeah, and then in general, we really encourage everyone to join a young professionals group if you're interested in a career in marine energy, and honestly, just renewable energy more broadly. Allows you to connect with peers, find some mentors, stay up to date on events and industry developments, expand your network. And so I think kind of to the point of what a few of our panelists said, that building your network is really important to discovering career pathways, as well as finding, jobs that are open currently is really important. So strongly encourage that. And then, like I said, this is a list of some newsletters and other online resources that can provide a lot of information about job postings, career pathways, ways to connect, things of that nature. And so I encourage you to take a look at all these resources and see if any of them stand out as something you want to kind of connect to.